In this video, I want to use GeoGebra again, but this time we're going to have a look at the graphs of hyperbolas. So we're going to put in two sliders, and we're going to use the same domains we have been using of -10 to 10. This is our first one, second one. Just move them over a little bit so we can see them. All right, now the equation of a hyperbola looks like y equals a, so some number, over x, and then plus a constant term on the end. So that'll be our b. If we hit enter, if we drag our b down to 0 for a second so that we don't have a constant term on the end, this is the most basic equation of a hyperbola. So it just looks like y equals 1 over x. And it looks like this here. So we've got two parts to this graph. And for this particular parabola, so this one with equation y equals 1 over x, it will never cross this y-intercept or the x-intercept. So it'll get infinitely close to those axes, but it doesn't have a y-intercept or an x-intercept. It never crosses those lines. What we call those lines are asymptotes. So asymptotes are lines that our curve will approach and get ridiculously close to, but it'll never actually touch. All right, so let's play with the coefficient of that x term. So that's this number up the top. So at the moment it's 1. If we make it bigger, we can see that that corner of our curve is less sharp. So it sort of flattens itself out a bit. As we bring it back towards 0, that gets sharper and sharper. And as it turns negative, it's going to switch into the other two quadrants. So if that number on the top is negative, so we've got a negative 3.4 at the moment, then it's going to have it in the second and the fourth quadrants. And again, as the number gets bigger, it gets a little bit flatter. All right, what we call these is an increasing function and a decreasing function. So we can tell which one's which by moving to the right across our graph. So as we move to the right, we can see that this value is getting smaller and smaller. And if we move to the right on this section, that value is decreasing as well. So if it's in the first and the third quadrants, then our hyperbola is decreasing as we move to the right. If it's in the second and fourth quadrants, as we move to the right, it's increasing. So our curve is increasing as we move to the right. All right, so that tells us what that number on top of the x term does. Let's have a look at our constant. So this constant term on the end does a similar sort of thing as what it does in all of our other functions. So we've looked at parabolas and we've looked at cubics. And this term shifts that whole graph up or down. The thing that you've got to notice as well, though, is when that was 0, then we had an asymptote here along the x-axis. So this curve approached the x-axis but never touched it. If we move that up to, say, 1, our asymptote is now at y equals 1. So there's this horizontal line running across at y equals 1 that our graph will approach. It'll get infinitesimally close to it, but it'll never actually touch. So this constant, as well as shifting the whole graph up and down, it's also shifting that asymptote up and down as well. All right, so that's just a quick look at hyperbolas and what those different constant terms do.